Welcome to another podcast. In this episode, we're going to be taking a look at the repeated roots case, although this time we're going to do numerical example. The example that I have in mind is we're going to take a look at y double prime plus 6y prime plus 9y equals 0. And we're going to look at an IVP once again. So this can be y of 0 equal to 1, y prime of 0 equals 0 for the critical points here, or for the initial points. So the characteristic equation here is r squared plus 6r plus 9 equal to 0. And this should be a perfect square. That way we will have repeated roots, since it's supposed to be the repeated roots case. And indeed it is. We get the root negative 3, and it is repeated twice. And so we know from previous videos that one solution is given by e to the negative 3t, and our second solution is given by t e to the negative 3t, which means that the general solution is given by a linear combination c1 y1 plus c2 y2, or c1 e to the negative 3t plus c2t e to the negative 3t. And so now, in order to find the particular solution, I have to evaluate at each of the initial conditions. It's always a good idea to go ahead and write out y prime prior to doing this. So y prime is minus 3 c1 e to the negative 3t. And then here we've got to be careful because we're doing product rule. It's c2, and then I'll do all of this in here. Product rule says we'd get e to the negative 3t plus, or actually it would be minus 3 t e to the negative 3t. Okay, so with all of that together, in order to find the particular solution, we're going to set up the equation corresponding to y of 0 equal 1. So plugging 0 in for t here, we get c1 plus 0, t equal to 0. Notice that that's going to disappear, and that's got to be equal to 1. So that's easy enough. That says that c1 is 1. And then if we look at y prime of 0 equals 0, well, if c1 is 1, then I'm looking at minus 3 times c1, but c1's 1, so minus 3 plus c2. This, when t is 0, is going to give, let's see, 1 minus, when t is 0, we're going to get 0 out of that. And all of that needs to equal 0. So this looks like it says minus 3 plus c2 equals 0, or c2 equals 3. So we've got our two constants. And so our solution here is 1 times y1, so e to the negative 3t, plus c2 times y2. So this is our particular solution in this case. All right, it's really a fairly simple process as long as we understand what the fundamental set of solutions is and where it comes from. This is an important case. It's oftentimes called the critically damped case when we look at the spring mass equations coming up next week. This will be the critically damped case corresponding to two repeated real roots. Now, we're going to look at the complex case in the next videos. We're actually going to go back and review a little bit of complex variables as well, so stay tuned for those videos. All right, thank you for watching.